So in this example, we have the Borman Creek Hand Sanitizer Company. They sell one bottle of hand sanitizer for $17 on their website, and then they charge $10 for shipping, regardless of how many bottles you buy. So if we're looking to make a relationship between the number of bottles and the cost with shipping, one way of thinking of that is trying to figure out how many bottles you need first and then what the cost of that's going to be. And to me, it's kind of set up to do that. So you have the number of bottles.
Every bottle you buy is $17.
So if you buy 2 bottles, it's 17 times 2. If you buy 3 bottles, it's 17 times 3, etc. And then an extra $10 for shipping. This is the cost. The unit of this entire sentence is dollars. Cost is in dollars. This side of the equation is in dollars. But you could also think of it differently. You could say, what if I want to know how much hand sanitizer I can buy for a certain cost?
That's just going to be solving for B.
So the first thing to do, get rid of the weakest operation. Then get rid of the next weakest operation. And this equation will give you, if you know how much you want to spend, and you want to see how many bottles of hand sanitizer you can buy, you subtract 10 and divide by 17, and that's the number of bottles. These two equations are inverses of each other. It's the exact same thing, it's the exact same relationship, we're just looking at it from different perspectives. So we can think of C as a function of B, or we could think of B as a function of C. We could think of the number of bottles we want to buy as a function of the cost. And it really depends on what's on your mind. Is how many I need to buy a whole bunch of bottles, what's that going to cost me, versus I have a certain budget to buy hand sanitizer, how many bottles can I buy for that? Neither way is better or worse than the other, but they are taking two different perspectives on the same situation. The thing is that in this version, the domain is number of bottles. In this version, the domain is money. This problem is very similar to that, except it's not going to be as obvious what the input and output is because it's just a bunch of numbers. It doesn't have any context to go with it. That said, we can still find the inverse of this equation. This we're going to plug in x and find out y. The other version we're going to plug in y and find out x. And keep in mind that f of x is just a fancy way of saying y. So we're going to call this y equals 2x minus 1 cubed plus 4. And again, we're looking for the inverse equation. And if you have y equals f of x, and then you do the inverse equation to both sides, on the right-hand side, f inverse will undo the f, and you're just left with x. And on the left side, you just have f inverse of y. So in this version, y is the input and x is the output. In this version, x is the input and y is going to be the output. So we're going to solve this just by reversing the order of operations. We're looking for the weakest operation to undo. So we're going to subtract 4 first. then multiplication and division. Then exponents or roots. And then we opened up the parentheses, so we're back at the bottom and looking for addition or subtraction to undo. I'm putting it at the front because sometimes it's hard to know where that square root ends. So just for the sake of ease of reading the answer. Sorry, this is a cube root, not a square root. All right, so now you have a function where y is the input and x is the output. And this kind of thing, it's nice to think of as f inverse of y. It is the thing that undoes f, and the output of the original is the input of this version. Here's the kicker, though. Mathematicians are lazy or efficient, depending on who you ask. And we typically don't like to put y's as the inputs of anything. I don't know why. So a mathematician will usually write this, regardless of if it makes sense or not, as a function of x. X is just the standard input for any function. Doesn't change anything except the variable that's used. But do keep in mind that the x you see here and the x you see here are not actually the same x. It's not actually the same input. One is the input of the function, one is the input of the inverse function. And so this x is actually the range of this function, and this x is the range of this function.